Hello, my name is Higashino from Z Engineering. For the past 42 years, we have been working with steam traps. During that time, we have seen steam systems in many different factories. This YouTube channel is not meant to defend or promote office traps. Instead, we will talk about the real problem that's actually occur in steam system in the field, and how we have tried to find answers to those problems through our work on site. That is what this channel is about.
In the previous episode, we discussed the conditions where orifice traps do not work. We talked about steam piping management and condensate recovery systems. Today, we will discuss another factor: heat exchangers. Orifice steam traps are not devices that can be used everywhere. There are clear conditions where they work. If those conditions are not satisfied, temperature becomes unstable, and production can be affected. Today, I will show clear examples where orifice traps do not work. There are two basic criteria. Condensate flow must be stable, and the differential pressure must also be stable. If either of these conditions collapses, an orifice trap cannot operate properly. The first case is superheated steam. Superheated steam does not condense immediately. It must first cool down. Then it returns to a saturated condition. Only after that does condensation begin. This means the amount of condensate is extremely small. As a result, the orifice size must also become very small. In this range, rust, scale, and clogging risks become much higher. In superheated steam piping, orifice traps generally cannot be used. The second case is direct steam injection. In this process, steam is injected directly into the product or material. The steam condenses immediately and provides heating or sterilization. As a result, the condensate often contains impurities, oil, debris, foreign materials. These materials can easily clog an orifice. Under these conditions, an orifice trap cannot be used. Typical examples of direct steam injection include canning factories, retort sterilization processes, steam sterilization in food production, low temperature vulcanization in rubber processing. In these processes, orifice traps are not suitable. The third case involves heat exchangers, where steam usage cannot be clearly controlled. The problem is not the heating process itself. The real problem is that the steam flow range cannot be clearly defined. For example, the amount of raw material changes from batch to batch. The condition of the material also changes. In some plants, steam flow is not controlled automatically. Instead, operators adjust the steam manually. Under these conditions, steam consumption can change significantly. In this type of process, orifice traps should not be used. Typical examples include chemical reactors, where raw material conditions vary each batch, heating processes for resin or rubber mixing and melting, food processing plants with frequent product changes where steam flow is not automatically controlled. In many cases, the key difference is simple. Is the steam controlled by a temperature program or by manual adjustment? This difference is critical. The fourth case involves multiple heat exchangers. When condensate from several heat exchangers is discharged through a single trap, the condensate flow can vary widely. The operating conditions change constantly. Under these conditions, it becomes impossible to design a safe orifice size. A typical example is the cylinder dryer in paper mills. Condensate from multiple cylinders is discharged through one trap. When the system stops, condensate accumulates inside the cylinders. When the system restarts, A large amount of condensate is suddenly released. This causes extremely unstable condensate flow. Under these conditions, an orifice trap cannot operate properly. Let us summarize. If condensate flow is unstable, orifice traps cannot work. If differential pressure is unstable, orifice traps cannot work. If either condition exists, the orifice principle does not hold. In processes where the conditions are not satisfied, the correct decision is simple. Do not use an orifice trap. That is the correct way to apply this technology. In the next episode, we will discuss the opposite situation, heat exchangers, where orifice traps work very well, where they can deliver their best performance. We will explain those conditions in detail.